In a quiet room on a quiet table rests a box. It is sealed, silent, waiting. Inside that box lies a cat. And according to quantum physics, the cat is both alive and dead at the same time. This is not a metaphor. This is not exaggeration. This is the frightening implication of quantum mechanics. A theory so successful it describes the behavior of the universe with unimaginable precision, yet so strange that even the physicists who invented it could barely accept what it meant. This is the story of Schrödinger's cat, a paradox born from genius, and a window into the deepest mystery the universe has ever shown us. The year is 1935. The world is still waking up to the unsettling revelations of quantum mechanics. Heisenberg's uncertainty, Bohr's complementarity, superposition. A universe where particles behave like ghosts, occupying many states at once. But one man, Erwin Schrödinger, feels something is wrong. Quantum theory works flawlessly, but its interpretation, its meaning, its implications, they terrify him. He believes something in the logic has gone too far. And so he decides to expose the absurdity, not with equations, but with a story, a thought experiment so shocking it would echo through time. He imagines a cat whose life depends on the behavior of a single quantum particle, a particle so small yet capable of bending reality. Imagine the box, sturdy, opaque, unbreakable. Inside it lies a simple device, a tiny vial of poison, a Geiger counter, a small amount of radioactive material. Radioactive decay is one of nature's purest quantum events. It follows no predictable pattern, only probabilities. Within the next hour, the radioactive atom may decay, or it may not. If it decays, the Geiger counter triggers a mechanism that shatters the vial, releasing poison, killing the cat. If it does not decay, the cat survives. A single quantum event decides its fate. But here is where quantum mechanics becomes terrifying, according to the theory. The atom exists in a superposition, both decayed and not decayed, until observed, which means the mechanism is both triggered and not triggered. The poison is both released and not released. And the cat is both alive and dead. A living corpse suspended in quantum uncertainty. One animal, two contradictory states, one box, infinite doubt. To understand Schrödinger's point, we must journey inside the mathematics of quantum theory. Before being measured, a quantum particle is described by a wave function, a mathematical cloud of probabilities. The particle does not have a definite position or state or outcome. It exists in many possibilities simultaneously. This is superposition. A particle can be here and there, spin up and spin down, decay and not decay. The wave function collapses only when observed, choosing one reality from the many. But Schrödinger asks, if a particle can exist in two states, and the cat's fate depends on that particle, does the cat also enter superposition? Is the cat alive and dead until the box is opened? Does superposition scale from atoms to animals to us? Where does it stop? Does it stop at all? Schrödinger never wanted the cat to be believed. He wanted it to be feared. He wanted physicists to see the absurdity of assuming the quantum world and the classical world followed the same rules. To him, the idea of a half-dead cat was not a prediction. It was a warning, a sign that quantum mechanics, properly interpreted, should never lead to such madness. But the world did not respond the way he expected. Instead of rejecting the paradox, physics embraced it. Because the math was clear, quantum mechanics works. And if the math says the cat is in superposition, then maybe the universe is far stranger than Schrödinger dared to imagine. Let us return to the box. You stand before it. Your hand hovers above the lid. Inside, probability reigns, a world of uncertainty, a suspended story with two endings. You open it. In that instant, the precise moment of observation, the wave function collapses. The universe discards one version of reality and commits to another, alive or dead. One truth replaces infinite possibilities. Your observation forces the universe to choose. This is the observer effect. Not that consciousness changes reality, but that any interaction capable of gaining information collapses the wave function. Measurement creates the result. Before measurement, the result does not exist. This is not philosophy. This is experiment. Schrödinger's cat is not about cruelty. It is about clarity. It reveals something shocking about the universe. Reality is not determined until it is observed. Particles exist in a fog of potential. Events unfold as probabilities. The world does not decide until it must. And that raises a terrifying question. If particles need observation to become real, then what is the universe before anything observes it? A silent wave of maybes? A cosmic sea of superpositions? Does reality exist independent of observation? Or does observation create reality? The cat's paradox forces us to confront this question. For nearly a century, physicists have battled to explain Schrödinger's cat, and no single interpretation has won. 1. The Copenhagen interpretation. The orthodox view, the cat is both alive and dead until observed. Reality is probabilistic. Observation collapses the wave. 2. Many worlds interpretation. A radical yet elegant idea. The wave never collapses. Instead, the universe splits. In one universe, the cat is alive. In another, it dies. Every quantum event creates new branches of reality. 3. Hidden variables. Perhaps the cat has been alive or dead all along, and we simply lack the information, a comforting idea, but one disproven by experiment after experiment. 4. Decoherence. A modern perspective. Superposition exists, but the environment destroys it instantly. The cat is too large, too warm, too connected to remain in a quantum state. Yet, the core mystery survives. Why does quantum behavior vanish at certain scales? Where does the boundary lie? The cat still sits at the edge of our understanding, a bridge between the quantum and the classical, between what we know and what we fear to admit. There is something unsettling about Schrödinger's cat, something personal, because the cat is not just a thought experiment, it is a reflection of us. We live our lives suspended between choices, futures, and possibilities. Before we act and before we observe, our destinies feel fluid, undefined. The quantum world is not far away. It is inside us. It builds us. It shapes every atom we are. We are children of probability, born from uncertainty, bound to a universe that does not reveal its cards until the last possible moment. Modern experiments have taken Schrödinger's nightmare closer to reality. Physicists have placed molecules, thousands of atoms, into superposition. They have created tiny mechanical oscillators that vibrate and do not vibrate simultaneously. They have built quantum computers that rely on superposition to calculate in many worlds at once. We are inching closer to a macroscopic Schrödinger's cat, not a living animal, but something large enough to challenge the boundary between the quantum and the classical. And every step forward brings the same unsettling realization. The universe is not built from certainties, it is built from possibilities. The box sits before you again, silent, closed, unrevealing. Inside, the cat waits, alive and dead, real and unreal, suspended in the fog of quantum possibility. It is not just the cat whose fate is uncertain, it is reality itself. For in every moment, the universe is a box, a sealed container of infinite potential, a place where worlds overlap, where futures coexist, where possibility reigns. And we, as observers, open the box with every action, every measurement, every glance. We collapse the wave. We carve one reality from the many. We shape the universe simply by participating in it. Schrödinger's cat is more than a paradox. It is the mirror the universe holds up to itself. A reminder that beneath everything we know, beneath every atom and every star, lies a hidden truth. Reality is not fixed. Reality is chosen. Reality is born from the act of observation. And somewhere, in the quiet dark of quantum possibility, the cat still waits.